So we'll continue with our conversions. So I have taken these questions. So you have to convert propane 1 to propene first. Okay, so we'll draw the structure. Propane 1 means ketone group is there. Propane is 3 carbon. So we'll have a 1, 2, 3 carbon. Ketone is obviously at the center, so it's H3, H3. So propane 1 to propene. Now propene, so it has a double bond now. CH3, CH, CH double bond CH2. It's a propene, right? So first you have to count the carbon. So it's 3 carbon, 3 carbon. So no need to increase or decrease the number of carbon. Now double bond is there, right? So double bond means we have to do the elimination reaction somewhere, right, to get that double bond. You have to keep that in your mind. Then this has to be removed. So so first we have to do the reduction part. So reductions we can use the sodium borohydride H4. So then it will be converted into CS3, C double bond C, so it will be H, right? So here comes H, CH3. Now we know that this is our elimination reaction, right? So elimination means something chloro or bromo has to be there. So from here you can do the direct acid catalyzed dehydration also. So when you do acid catalyzed dehydration, so it's H3O plus acid catalyzed dehydration, then it will result in the formation of this. Okay. Or if you want to go in a bit longer way, so you can go for the SOCl2, then it will be CH3, okay, CH, here comes Cl, CH3. Then you can go for the elimination reaction. Okay, so it's a alkaline, alkaline KOH, right? So, sorry, alcoholic, ALC, alcoholic KOH is for elimination reaction. So if you do, then this is alpha carbon, beta carbon, okay, so from alpha Cl will come out, beta from beta H will come out, so and that way you can do. So you can do in either ways. Right, so first part is your reduction part, then you reduce this ketone to a secondary alcohol, okay, then from here you can directly do the acid catalyzed dehydration, or you can follow the SOCl2, then Cl will come, then you can do the elimination reaction. Now coming to next one, that is benzoic acid to benzaldehyde. So first we'll draw the structure. Benzoic acid, so benzene with COOH, and we have a benzaldehyde. So benzaldehyde is your CHO. Okay, so basically we have to do the reduction. Okay, so reduction part, normally what we do is we will add again here also SOCl2, then it will be something C double bond O, Cl will come, right? So from this to this, you know it, which is which reaction? It is Rieselman reduction. Yes, so Rieselman reduction, so it's H2 palladium H2, sorry, it's barium sulfate, PaSO4. When you do the Rieselman reduction, then you will end up with the benzaldehyde. Okay, the next conversion is ethanol to 3-hydroxybutanol. Okay, first we'll draw the structure. Ethanol, okay, so it's a CH3CH2OH. So we have ethanol here, then it's a 3-hydroxybutanol. So but is the water, so 4 carbon, aldehyde is there. So 4 carbon, 1, 2, 3, 4 carbon with aldehyde. So butane all there, then 3-hydroxy. So 1, 2, 3. So 3, okay, I'll just write 3-hydroxybutanol. So here comes H2, H3. Now you have to do the carbon count. So here is a 2 carbon, here it has a 4 carbon, so the double, right? So double means which reaction is there, phytic reaction is there. Then another is some condensation reaction, so you have to think. Or you can do for the RMGX. So from there you can, from Grignard reaction you can add the number of carbon. But looking at this one, if you look clearly, then this is the function group and this alpha beta. So beta hydroxyaldehyde. So got it? So beta hydroxyaldehyde is the product. That means it is a aldol condensation. So you have to do the aldol condensation. But for aldol condensation you need either aldehyde or ketone, right? So since it has aldehyde, so if you break this one, you can think that it will be CH3 COOH. So if I choose this one, dilute NaOH is the reagent. Okay, so yeah, suppose CH2 negative by COOH, right? So it will extract the alpha hydrogen, right? So I'll take out the alpha hydrogen, so it will attack here. So check the product, CH3 C, this OH, okay, then it will be CH2 Ca. Yes, so we are getting this exactly two products. So basically this is your aldol condensation. So basically, so we have to write here two molecules, okay? So I'll omit this. So this part is your aldol condensation. Now we have to convert this to this. So alcohol, that is our primary alcohol, to aldehyde. So as already discussed, we have to do the oxidation, but that is control oxidation. So for that control oxidation, we have the reagent PCC, that is pyridinium chlorochromate. So that will do the control oxidation. Okay, so we have primary alcohol, you do the control oxidation, so you will end up with aldehyde, then you do the aldol condensation. Okay, so this part is your aldol condensation. Now the next reaction I've written here is benzene to meta-nitrophenone. Okay, so this is benzene. Then we have a meta-nitroacetophenone. So we have to choose the product. So meta-nitro. So meta-nitro is the acetophenone. Is CH3. Okay, so for introducing the nitro group, you have to do the nitration. Okay, the reagent is concentrated sulfuric acid and concentrated nitric acid. So when you add concentrated sulfuric acid and concentrated nitric acid, nitration takes place. That is monosubstitution. Okay, NO2 gets inserted. But can nitrobenzene undergo this? So we have to add C-double-bond-O-CH3. From which reaction we can add this one? It's basically a Phenyl reaction, right? So from Phenyl reaction. So, but this meta-nitrobenzene is a very ring deactivating group. Okay, so it does not undergo Phenyl reaction. Remember. So that means first part we have to do the Phenyl reaction. That is Phenyl alkylation or acylation. Okay, so for that we have to choose this product. So CH3 C-double-bond-O-Cl. Okay, so acyl chloride. So CH3 C-double-bond-O-Cl. Then I do the Phenyl reaction. Okay, so for the reagent is anhydrous. Anhydrous AlCl3. So if we do this Phenyl reaction, then our product will be C-double-bond-O-CH3. Now this group, okay, C-double-bond-O-CH3 benzaldehyde benzoic acid. These three are meta-directing group. Remember, okay. जब कि हम alkoxide benzene if we have this one OCH3, then this is a para-directing group. But here is slightly different, right? So here is the structure. It's C-double-bond-O-CH3. You have a meta-directing group. Remember. Okay, you have a meta-directing H. This is also meta-directing again COOH. You have a meta-directing group. So meta-directing for incoming electrophile. So nitration now next is. So that is concentrated H2SO4 plus concentrated HNO3. So that will be the monosubstitution nitration at meta position. Okay. The next reactions I have taken here is benzaldehyde to benzophenone. Benzaldehyde. So benzene with CH group is benzaldehyde. So we have this benzaldehyde. Next is benzophenone. So one side benzene and another side phenone. So it's basically benzophenone as this group. So benzophenone. So benzaldehyde to benzophenone. So that means you have to add one more benzene ring here. So how can we achieve? How can we achieve? See, if you see like this side, if you here, and if you put here Cl, okay, if you put Cl, so it's a acid chloride, so benzene C double bond O Cl, then another this benzene ring. That means we are doing the phenyl reaction here, okay, in the second part. So we have to put one benzene. So we have benzene with C double bond O Cl and benzene ring. If you do the phenyl reaction, we are supposed to get this product. Okay, so we need benzene with C double bond O Cl. So we need here Cl. So how can we get Cl? So first thing is you have to make this as a carboxylic acid. So basically oxidation. Okay, so you do the oxidation here. Oxidation is acidic K2Cr2O7. Acidic K2Cr2O7. You can do it, or you can, if you use alkaline MnO4, that's okay. In the second step you have to use acid. Otherwise you can use this one. Then it will be converted into C double bond O, strong oxidizing acid. Now you can add here Cl. The simplest is SOCl2. So you are getting benzene double bond O Cl. Okay. Then I said you have to do Friedel-Crafts reaction. So add benzene, one more benzene. Okay, plus the reagent is anhydrous AlCl3. Anhydrous AlCl3. If you do it, then this group will attach here, and you are supposed to get the required product. Okay, you have to think like this, and you have to perform the conversion. The next is bromobenzene to 1-phenyl ethanol. So we'll first draw the structure. Bromobenzene Br, right? Then it's 1-phenyl ethanol. So ethanol is the main one group. So it means 2 carbon, all means which group is there? Then 1-phenyl. So this carbon number 1, it has benzene ring. So benzene as a branch is called phenyl. So you need one more H here. So H3. So this is your 1-phenyl ethanol, right? Okay, so how do we perform this reaction? So I have already mentioned that this bond is very strong. So the only way to break out this is the production of Grignard reagent. So Mg, we put Mg, dry ether. Then you'll have something like this, MgBr. Remember, there is a 2 extra carbon here. Okay, so benzene Br. Now that means here. So you have to add 2 carbon. So okay, so and OH group is also there. Okay, then this is one famous reaction of Grignard reagent with aldehyde. Okay, so we'll try with that one because this is our secondary alcohol. If you look at clearly, this carbon has 2 branches here and here, so it's secondary alcohol. Secondary alcohol. The production of secondary alcohol from Grignard reagent uses aldehyde. Aldehyde means yes, aldehydes having CR group, right? Not the formaldehyde again. So we'll use suppose CH3 C double bond OH, right? Then according to the mechanism, it says that okay, the bond will break here, it will hit here, the bond will go up, then the magnesium will get attached here. Okay, so we'll write up this. Here comes. Okay, so this will attack here. So it is C. CS3 is as it is. This CS3. Then there comes O. Here comes Mg, Br, and H is already there. See? This will attack here. So attack here. So CS3 here. CS3 I have written in this way. Okay, so H is already there. O. Fine. Now if we do the acidic hydrolysis positive. Okay, then normally it gives H plus and OH minus. H will attach here. So we are getting this one. Yes, H will attach here. So CH3 COH and plus MgOH and Br will be as a side product. Okay, so from this way we can do the conversion. Okay, the next reaction is your benzaldehyde to 3-phenyl propane 1-ol. Right, so we'll write the structure. Benzaldehyde is benzene with CHO group, C HO group, and we have a phenyl propane. Prop means 3 carbon, 1, 2, 3, 1-ol, 1 OH, and 3 phenyl. 3 means here. So this is the one. So H2, H2, H2. Okay, so we'll start with this one, that benzaldehyde. So 2 carbon is extra, right? So, and alcohol is also there and O has been removed. Okay, so okay, we'll try with a cross aldol condensation. CH3, C. Because we need 2 more carbon, so we are taking this group. So dilute NaOH. So this will take your alpha hydrogen. Okay, so alpha hydrogen. So this becomes your CH2C double bond O H dot negative. Now this will attack here. Right. So we'll write the equation from here. That is benzene ring. C, this becomes OH, okay, H is already there, and here comes this CH2C double bond OH. Fine. The next step is we have to heat. Normally it is followed by the heating, which it results in the liberation of water. So alpha beta, so beta hydroxy aldehyde, right? So it will release the water from here. So it results in the formation of this compound CH double bond CH, right? So this is alpha beta, right? So alpha beta unsaturated aldehyde. Now from here, if we do the as we do in the case of double bond. So if we do here, so the two H will come here and H will come here again. One H will be come here and another H will be come here. Okay, so ultimately it results in the formation of this compound. Got it? So if I write OH, it will be exactly same. So hydrogenation with the help of nickel. Okay, nickel catalyzed hydrogenation. If you do it, then it results in the desired product. Okay, the next reaction is benzaldehyde. So we have to take benzaldehyde is C double bond O. So it's benzaldehyde, then it's a alpha hydroxy phenyl acetic. So acetic acid is the code word. So it's a common name basically. So acetic acid is a CH2. It has a 2 carbon, right? OH. Then alpha. So this is alpha position. Alpha has a hydroxy group. Okay, so I'll write here OH, alpha, and phenyl. Phenyl obviously it won't go because all are filled. So here is one phenyl. Okay. So it's a phenyl. That means one hydrogen is here. So this is your alpha hydroxy phenyl acetic acid. Okay, so one carbon is increased. So one carbon means normally we have to do this step of reaction, but here this step of, because we have to protect the O also. So yes. And okay, we'll do one more thing is that we'll add KCN and HCl. Do you know this cyanohydrin reaction? Cyanohydrin. It will form a cyanohydrin. That is CN will attack here. Okay. And this H after that, the O negative will be there, the O negative, the H will come here. So it will form cyanohydrogen compound. C, it will be, okay, so it will be OH, here is CN, right? Yes. So if we do CN, okay, so one part is solved. Now this CN has to convert into COOH. Simple, that is acid catalyzed hydration. If you do the acid catalyzed hydration, then CN will convert into COOH. I think we got the product. Benzene ring, CH, OH, COOH. Yes. In this way we can do the conversion. The next one is benzoic acid to meta-nitrobenzoyl alcohol. Okay, this is the last one for today's lesson. So benzoic acid. So first we'll draw the structure. Benzoic acid. Benzene with C double O OH. And we have the meta-nitrobenzoyl alcohol. So benzyl alcohol. Okay, so first we'll do the benzyl alcohol. Benzyl alcohol is benzene with CH2OH. And here is the meta-nitro. So nitro comes here. Okay. So our main intention we have to have is to introduce nitro here. Okay, so C-double-OH is a meta-dieting group for incoming electrophile. So there is no problem in nitration. So we can do the nitration. Nitro group comes here. Then the next problem is we have to convert the COOH into CH2OH. Okay, so reduction part is there. So we'll do. Okay. So first is nitration. So it's a mixture of concentrate H2SO4 plus concentrate HNO3 nitric acid. So when you do it, then it will be form a meta substitution. Okay, it's a C-double-O OH and nitro groups comes here. The next problem is we have to introduce here this CH2. So it's carboxylic acid, this is alcohol. Okay, so before doing the reduction, we are supposed to use SOCl2. So that will replace this OH. So C-double-O, yes, Cl. Now we can do the reduction part. Done with the followed by acid catalyzed hydration. So if we do it, then the Cl will be replaced by OH group. So thank you.